Hello everyone, welcome to JEE Main Solution 2020. In this video lecture, I'll be solving question number 6 to question number 10 of the JEE Main Examination 2020, which was held on 8th of January, Shift 1. Starting with question number 6, if two capacitors C1 and C2 are connected in parallel, then equivalent capacitance is 10 microfarad. If both capacitance are connected across 1 volt battery, then energy stored by C2 is 4 times C1. Then find the equivalent capacitance if they are connected in series. As you can see guys, in the 6th question, they have said that there are two capacitors. They are connected in parallel to each other. Let me call the first capacitor as C1, second capacitor as C2, and both of them are connected to a power supply having potential difference is equal to 1 volt. Now, which means potential difference across C2 is also 1 volt, C1 is also 1 volt. That is pretty clear since they are connected to same power supply. But in this case, they have given the effective capacitance in the parallel scenario is equal to 10 microfarad. That's the data. Now the question is demanding us to find the effective capacitance of the same two capacitors if they are connected in series. Now let's try to find them, but before that we need to figure out how much is the individual capacitance. Then it makes it easier to find their effective capacitance after connecting them in series. Now in order to find the capacitors, they have given us a hint that the energy stored in capacitor C2 is equal to 4 times energy stored in capacitor C1. We have three different formulae for energy stored in capacitors. That is, one is half CV square. Okay, one formula is what? Half CV square. Another one is half QV. And the third one is Q square upon 2C. Now among these three formulae, I shall say we will use this one, half CV square, because we have data about V. Both are having same V, and we have some data related to C as well. So this one is much better to use according to my understanding. Half, here I'll write half C2 V square is equal to half C1 V square multiplied by 4. V square gets cancelled, half gets cancelled. This will give me C2 is equal to 4 times C1. Now since we have this relation, you substitute this C2 is equal to 4 times C1 over here. After substituting it over here, I'll be getting C1 plus C2 is equal to 10 microfarad. It is. Substitute this over here. I'll be getting 5 C1 is equal to 10. In short, C1 will be equal to 2 microfarad. This will be my expression for C1. Substituting the same value of C1 in this or maybe this, I'll be getting C2 is equal to 2 multiplied by 4, that is 8 microfarad. This is the value. These are the values of C1 and C2. You are supposed to find that what will be the effective capacitance after connecting these two capacitors C1 and C2 in series with each other. As we are very well aware that after connecting them in series, 1 upon Cs is called as 1 upon C1 will plus 1 upon C2. I am simply substituting the values 1 by 2 plus 1 by 8. Let me take the LCM. In order to take LCM, what will I do? I'll simply multiply on numerator and denominator with 4 so that I get a common denominator. This will give me 4 plus 1 upon 8, that is 5 upon 8. In short, CS will be equal to 8 upon 5 microfarad. And this is your final answer. Question number 7. A rod of mass 4m and length L is hinged at the midpoint of rod. A ball of mass m moving in the plane of the rod at an angle 45 degree strikes at the end and sticks to it. Find angular velocity of system after collision. In 7th question, you have a rod. Here is your rod. This rod is hinged from the center. That means this rod can freely rotate like this. Now, mass of this rod is given as 4m. The length of this rod is given as L. And there is a body, another body of mass m, which is approaching this rod with a speed v, making an angle 45, which means there will be two components. One component will be v sine 45, another component will be v cos 45. Since sine 45 and cos 45 both have same values, I shall directly write the values of components. Now, according to law of conservation of angular momentum, initial momentum will be equal to final momentum. Now, initial momentum. Initially, there is only this particular body which is moving. Angular momentum of this body will be equal to mv into r, where r is distance from the axis of rotation. In this case, the distance from axis of rotation will be L by 2. I can directly write it as L by 2. That will be equal to, in fact, v. v will not be v. v will be actually v upon root 2. And the final momentum, the whole system is going to rotate. I shall write I multiplied by omega. Now, speaking about the system, I have got two bodies in the system. One is rod and the other one is the particle body which is hitting the rod. I multiplied by omega. Now, after decoding, this is again mvl upon 2 root 2 is equal to moment of inertia of rod is 1 by 12 m. Here the mass of rod is 4m. Therefore, I shall write that as 1 by 12 m L square plus the body which is hitting. I shall write the moment of inertia of that particular body will be equal to mr square. mr, the r in this case is L by 2 square, that is L square by 4 multiplied by omega. Now again I am rewriting. I shall cancel do some cancellations over here as well. This will be L square by 4, this will be L square by 3. Doing some cross multiplication on LHS, I will be getting 4 plus 3, 7 L square upon 12 omega, and on LHS I will be getting VL upon 2 root 2. I will cancel one more L, taking all the terms on one side, making omega as subject. I can do one more cancellation over here. This will be 6, taking 6 on the other end, 6 V upon 7 root 2 L. This will be the expression for omega. Question number 8. There are two metals A and B. Energy of incident photons are 4 electron volt and 4.5 electron volt respectively. Maximum kinetic energy for ejected electron is Ta for A and Tb is equal to Ta minus 1.5 electron volt for metal B. Relation between wavelength of ejected electron of A and B are lambda B is equal to 2 times lambda A. Find work function of B. Now let us try to understand this question. Metal A has been irradiated with radiation having energy 4 electron volt, and B has been irradiated with an energy of 4.5 electron volt. The maximum kinetic energy of electrons emitted from B is Tb and the other energy is Ta. The relation has been given in the question, and the wavelengths also are related with a value with a factor called as 2. As per data, I have written everything. Now we are pretty aware that this lambda is equal to H upon P, where P can be connected with the help of kinetic energy. Here the kinetic energy is termed as T, so I shall write kinetic energy is equal to half mv square. We are pretty aware of it. When you multiply and divide by mass, what happens? The expression goes like this. It becomes P square upon 2m. This will give me P is equal to 2mk with a square root. You substitute it over here, the expression becomes square root of 2m. In this case, the kinetic energy is expressed as T, therefore I will write it as T. From here I can say that since H is constant, M is constant, 2 is constant, I can easily conclude that lambda is inversely proportional to root of T. Okay. Now, from here I can conclude that lambda A upon lambda B will be equal to root of TB upon TA. Since we are aware what is the expression of TB, I will write this as square root of TA minus 1.5. Everything is in his electron volt upon TA. Since lambda B is 2 times lambda A, I will cancel these two terms and write a 2 over here. I will take square root that side. It becomes 1 by 4 is equal to TA minus 1.5 upon TA. cross multiplication leads us TA is equal to 4 times TA minus 6. That will give me 6 is equal to 3 times TA, giving us TA is equal to 2 electron volt. Which means if I substitute this 2 over here, okay, TA is equal to 2. So that will give me 2 minus 1.5. That will be 0.5 electron volt. That will be the value of TB. Now basically what are we supposed to find? Find out work function of B. I shall call it as phi B. We know that energy of photon is divided into basically whatever energy of photon is coming, that is used in terms of kinetic energy, and some amount is used in terms of work function. Okay, in this case, if we are speaking about B, I shall name everyone with B. So EB they have given as how much? It is 4.5. I shall mention 4.5 electron volt over here. TB, we just found TB is equal to 0.5 plus work function. That means your work function will be equal to 4 electron volt. This will be your final answer. Ninth question. There is a potentiometer wire of length 1200 centimeter and 60 milliampere current is flowing in it. A battery of EMF 5 volt and internal resistance of 20 ohm is balanced on potentiometer wire with balancing length 1000 centimeter. Find resistance of potentiometer wire. In this question, I have written all the data over here. This is the total length of potentiometer wire. This is the current flowing through potentiometer wire. This is the EMF connected across the potentiometer wire. And the balancing length is 1000 centimeter, and this EMF is having 20 ohm of resistance. I shall just draw the same setup with the help of a diagram. Let me say this is your potentiometer wire. This potentiometer wire is connected with the help of a power supply, or maybe I'll call it as an EMF. EMF E is equal to 5 volt with internal resistance of 20 ohm. Now this is the jockey with the help of which we can see that this is the balancing point which is at a resistance of 1000. Now this 1000 is converted into meter, and I shall say that this is the total length. Meter will be the total length and 10 meter will be the balancing length. This is another power supply. They are having a main power supply. The potentiometer meter will be having a main power supply, due to which the current flowing through that particular power supply is given as I, which is nothing but 60 milliampere. Whatever is the potential difference of this particular EMF will be equal to this potential difference. Here the internal resistance is not going to play any role because there is no current flowing through this particular EMF, as this is the balancing point. Which means if this battery is having potential difference, or this cell is having potential difference of 5 volt, which means this piece of wire, I shall call this wire as A, B and P. This piece of wire will be having potential difference, that is potential difference across AP will be equal to 5 volt. Now considering the expression for potential gradient is nothing but potential difference per unit length. Now I can say that VAP upon LAP will be equal to total potential difference VAB upon LAB. Now what they have given, VAP is given as 5, LAP, the length is known as 10, VAB, that's what I'm trying to find over here, and LAB is 12. Doing some cancellations, in this case LAB is 12. So I shall multiply 12 with 5, or I'll simply do one thing. I'll cancel this and make it 1.2. I'll multiply 1.2 with 5. That will give me VAB will be equal to 6 volt. So this is the potential difference of the whole wire. Since I'm already aware how much is the current flowing through the whole wire, now I also know the potential difference of this whole wire. I'm supposed to find resistance of this particular wire. So the answer is pretty simple. According to Ohm's law, resistance is equal to potential difference upon current. The potential difference I just found it to be 6, and the current, they have already given the current is 60 milliampere. I'll do certain cancellations. The answer will be 100 ohm. This is your answer. 10th question and last question of this video. A telescope has a magnification of 5 and length of tube is 60 centimeter. Then find focal length of the eyepiece. This is a very simple question. Let's see how the solution works. This is the data of the question. They have given magnification as 5. They have given length of the tube, that is the telescope, as 60, and we are supposed to find focal length of the eyepiece. Magnification is nothing but FO, that is focal length of objective upon focal length of eyepiece. That will be equal to 5. This will give me FO is equal to 5 times FE. And the length of telescope is equal to FO plus FE. It's a simple formula based problem. And FO can be substituted with the help of 5 FE, and overall you will be getting length is equal to 6 FE, but this length is actually equal to 60 centimeter. When I substitute it as 60 centimeter, 6 and 60 gets cancelled. I will be getting FE is equal to 10 centimeter. That's it.